So forewarning, this is not a demo-intensive talk and should probably not be as interactive or potentially as interesting, because we're going to be dealing with recommendations, which means some texts and stuff. Let's jump into that. So the title of the talk, at least the public one, is Dissecting the ENISA Baseline Recommendations for IoT Security. The tagline for it is why no one can be arsed to be compliant. So we're going to get just deep dive into that. So first of all, a bit on myself. I am a Swiss hackademic. I know the term is a little bit cheesy, but I am in academia. I am pursuing an undergraduate degree in information sciences, and I am a software developer / OSINTier / whatever the rest in my day job. These are all my socials. I have a blog which I furnish semi-regularly, and that's about it. Yeah, otherwise I'm not explicitly interesting. I'm a very opinionated person on a few themes such as privacy, but that's about it. So the context that we're talking about is IoT. So IoT, I'm assuming you've all heard of it, is the Internet of Things. Internet of Things, some people see it as the entirety of the internet, every device that's connected. If you ask some other people, it's, some clusters of devices. So we're talking about service-centric clusters. So each pairing or group of devices that are part of a cluster are going to be, service-centric and are going to be one IoT network. So a very good talk on IoT and fun stuff you can do with that is so Smealam's DEFCON 27 talk, right, where he does that with teledildonics. So yeah, IoT, everything from smart homes to satellites, phones, sensors, city-wide sensor grids for pollution, all that stuff. And yeah, clusters are generally service-centric. Now, IoT has been taking a very big impact in our world since, I don't know, the 70s, from the appearance of TVs to, modern communications. The first million IoT devices, and we're talking about IoT in general, so that means also computers, was in 1992. So it's a thing we've known about for a while. Except the growth of IoT devices in the world, it has been slightly exponential. It's not exactly exponential, but we're getting there. And in 2020, we're at about 50 billion IoT devices. Now, that might not seem very much, but when you consider that that's about 6 or 7 IoT devices per person, and that they're all gathered in usually the Northern Hemisphere and quote unquote developed nations, that becomes an issue. So yeah, it's everywhere from home automation, logistics, environment, public health, automatic factories, all that stuff. And it's not only constrained to one type of technology. You have transmission technologies, so everything from cellular to Zigbee to Bluetooth Low Energy to long-range RF networks to some near-field communication things like RFIDs and all those chips on your banking cards. But it's also in many different types of technologies. It can be microprocessors or things microprocessors are built out of. And the state of IoT security is, there's this joke that's pretty prevalent that the S in IoT stands for security. It's a joke we're living with, and that's only recently garnering enough attention for, I don't know, standards committees and standards organizations like the ISO to actually do something about it. For example, the ISO IEC standards like 21823-2 standard, which was interoperability for IoT systems. So everything, data transmission for IoT systems is a standard that exists only since 2020. So that's a bit of an issue. And most companies slash people that, build IoT devices are doing so from recommendations or from practices that they've learned maybe 10, 20 years ago. And the problem is that the entire threat landscape has changed. So that's an issue we are dealing with nowadays. And other things that do exist are interoperability schemes. For example, there's the Bluetooth Generic Attribute Scheme, GATT. That's fantastic. It builds up profiles for different devices of the same type to communicate efficiently so that they can detect each other easily. That's fantastic. Those things rarely, if ever, consider security. So that's going further into why security is an issue. So later on, I'm going to work off of a practical example, but I'm going to give it here for some context as to why it's an issue. It's an IoT pacemaker. The one thing you wouldn't want to have something be connected to the internet or any other type of network is something which can stop your heart. So in this case, it's a very it's not an edge case, but a smaller case. Just transmits vital information to your phone, right? So the phone monitors for variations, tachycardia, other things, and sends things like device IDs, your heart rate, electrocardiogram data, all that stuff. And maybe, it also receives some data, like should it automatically attempt defibrillation? Most of the time, it's only internal systems that do that logic. But let's imagine that someone was, I'm not going to say stupid, but was careless enough to expose that to an open communication. So risks of that is like possibly inducing tachycardia into someone. It's fun. And also killing them, which is also fun. A little bit less fun, but still. So now that we have that small example, which I'm going to get to later, out of the way, there's this one acronym, 5 letters in the title, ENISA. What is ENISA? Well, it's the EU Cybersecurity Agency. An equivalent in, for example, the US would be the NSA or CISA. Potentially, you could find GCHQ there. Not entirely certain what the entirety of their mission is, but let's assume there's some parallels. And they've been active in the European Union, or the European space at least, since 2005. So what do? They generally publish recommendations of stuff that can be done, including what we're going to be dissecting today. And they host forums and conferences and many things where important people, the air quotes were intentional. There are some important people, but there are some, people that have less to say and that usually pay to go there, that are then brought together where they discuss issues like potentially cybersecurity. Now, another term that we're going to be talking about in the subtitle, I guess, there was the word compliance. So we're not talking about the legalese version of compliance. And a pretty easy way to see compliance is that it has something to do with security, but it is not security. So compliance, yet again, not the legalese version. I'm not a lawyer. I am also not versed in law, at least not enough. But in this term, in this use of the term, it's going to be following and adapting a service to recommendations, which have been vetted, of course. Now that intro has been done, I know it's a little bit of a long intro, here are the things we're going to see. We're going to see basically what compliance, not the legalese version again, entails, the contents and limitations of these recommendations, so the document I'm going to get to, and the key takeaways that we can, gather from all of this. So yeah, compliance and hurdles. One of the big issues with compliance is that you often have this service triangle the quality, speed, price triangle. You can only have two. You can only have a fast service and a good service and a cheap service, or a fast service and a cheap service. No three at the same time. So yeah, that's a bit of an issue. And so being compliant with these types of recommendations kind of brings you security as a headache. Wherever you work in a development chain for these types of things, whether you're a developer, a firmware developer, a QA tester, or one of the big C's, CEO or CISO or anyone else, security is going to come and bite you in the butt depending on where your issue is and what you're doing, what you're trying to attain with your services. Compliance is also required for interoperability. Sorry, my tongue jammed. For example, if you're using, let's say, two devices that need to connect, they would need to connect with some form of transmission system technology. If they need to connect to a phone, it needs to be something that is supported by phones. Being compliant with certain norms is sometimes required, is often required, actually. And there is a ton of limitations across the spectrum, from limitations as to what you can do with, let's say, how you connect to it, limitations on, let's say, data privacy laws, limitations on the time it takes. There's a ton of limitations, and we're going to identify 4 of them. First one is time. To be compliant, you usually have to do a ton of, let's say, tasks that take a lot of time. You might want to do some, threat modeling, some testing, some pen testing, additional tests, some quality assurance, a lot of things. And all of that is usually going to stack up onto or after a period of design, a period of conception, a period of development. So that's a bit of an issue. And the drawback is that sometimes some people, usually higher up than the people actually working on this, are going to take some managerial / executive shortcuts, saying we don't need this, or we're going to get to that later. And that's a big issue. Second hurdle is costs. So usually when you're developing something, you have engineering costs, especially in IoT, you need to produce something. If it's a smart light bulb, then you need to produce a smart light bulb. You also have, salaries, because usually people get paid. And you might also need to pay for external audits for additional things. Now, the third hurdle is people. And I'm not saying this to be mean, because it's not that every person is an issue. It's that sometimes you need a very specific set of skills to do a very specific task. You would need potentially, a pen tester. You are probably not going to have a pen tester on staff the entire time. You might, contract that to a company. Yeah. Your employees might, have stress. That's a major issue. I mean, we're living in a pandemic. Everyone is stressed. Mental health of everyone is, well, not everyone, but it's usually down in the dumps or somewhere a little bit higher than that. And everyone's coping. So yeah, that's a bit of an issue. And the third thing is that, if you're having a project on 5 years, well, people tend to move around. Some people, go away for, personal life. They find someone, they marry someone, they have kids, they want to move out in the world, change cities, have to move back to their parents. It's a big issue, and so that's something that needs to be accounted for as a hurdle. The last hurdle is quality. Centered on a few notions, like, is what you're doing documented? Like, can someone else jump in after you, or take up whatever project you're doing and potentially reuse it. Is it effective in what it does? Does it do it in any way, shape, or form that is at least performant? And is this quality consistent over all of the services, or let's say pieces of services that you build? Right. Now, that was a lot of words. And we've not even gotten to juicy bit yet. Juicy bit is this book-ish from November 2017, published by the ENISA. It's all public domain. Problem is, it's 103 pages. It's mastodon. The thing that is not a problem is that only 7 of those pages are actually interesting, for at least the contents of this talk. The rest is everything from higher level recommendations, how would you need to implement this at a bigger scale, what are the risks for IoT. Fantastic mastodon of a document. But only 7 of those pages are going to be interesting, which is still, it's a lot, because it's 7 pages, but it's 80 recommendations in 3 categories. And that is what we're going to go through right now. So I've done a little bit of, aggregation. And I won't be putting up 80 bullet points, because otherwise we'll be there next year. And we're only at the beginning of 2021. So it's divided in 3 parts. The first part is policies. So first policy is security by design. All these things usually come down to a buzzword we've all heard, depending on where you work in the industry of information security or development. So yeah, these buzzwords are somewhat explained, at least in the concept of the document. Privacy by design is also one. Asset management, and risk and threat identification and management. No, and assessment, sorry. So security by design. What does that entail? Well, a consistent and holistic approach to security. You need to integrate security at all points of development. As you can see, I've added the little icons from our herders earlier. Green is, if the icon doesn't appear, it's okay. It doesn't register. Green is we register it. Orange is okay, and red is oops. It's going to take a lot of set resource. So yeah, integrating security at all points of development. So holistic approach. Frequently test and evaluate security. That's also pretty important. And consider human security, which no one does. Well, not no one, which is rarely considered when doing IoT devices. When I jump back to our example earlier, human security would be that nothing can trigger, let's say, a electric shock, that to restart the heart or to fix tachycardia. That would be an aspect of human security that would need to be considered, right? It needs to be able to evolve. It needs to, think about security before thinking about power conservation. Even if you're working off of a small battery, you need to take security in first and then the power considerations. And all this also, has test plans, includes code reviews, all that kind of jazz. Right. Second point is privacy by design. So privacy by design is bake in privacy. I know that sounds a little bit, I'm not going to say ridiculous, but not for, it sounds a little bit, let's say, part of a utopia. Privacy needs to be an integral part of the system. No privately identifiable, no personally identifiable information should be transmitted unless extremely necessary, and then we need to encode it, encrypt it, and send it somewhere else. I mean, sure, but who takes the time, sadly? So what else is, privacy impact assessments. So when you're launching an application, a service, a device, something of that sort, doing a privacy impact assessment is a, let's say, time-consuming task, which also needs to be extensively documented, and there needs to be a report. Report needs to be read by someone, validated by someone else, signed off on. Company life. Asset management requires procedures. Yes. So these procedures need to be established. You need to have certain configuration controls for key network and information systems. You need to have all this that works, at least at a certain time. The worst part is maintaining that, because every time you add an asset, you need to register it. You need to identify it, be able to find it again, be able to see conflicts. It's a pretty hard domain, let's put it that way. And risk and threat identification and assessment. It's basically identifying risks. Some people prefer the defense in depth approach. That's the one that's recommended in the document. So defense in depth being, a series of defense mechanisms that are, stacked up upon one another. And the idea is to basically protect the core element of it. You may have heard of it on TV by a certain lawyer for a certain ex-president that basically talked about triangles and waving things in the air. No, it's actually a very serious thing. And the other part of threat identification is to identify where your service needs to work. It needs to be, let's say, if you have a service that, I don't know, an IoT device that checks when a bus is at a bus stop, a pretty, something that you need to consider is that, okay, there's going to be harsh weather, it's going to be cold. Someone might actually just go ham on it with a hammer. Things need to be identified, and yeah, all the risks need to be accounted for, or at least the ones that are important. The second part of this document concerns organizational, people, and process measures. It's divided in 5 parts, subparts. End-of-life support, using proven solutions, vulnerability management, security training, and third-party relationships. Well, we're steadily hashing through all of this. Don't worry about it. So, end-of-life support. There's a very common example I like to point out. It's smart light bulbs. They usually are bought, work for about 1 or 2 years, then don't work anymore. Or they have a 10-year guarantee, and 3 years in, the software, the application doesn't work for that anymore because oh yes, we have a new model. So having and developing an end-of-life strategy is pretty important. That includes clarifying the extent and range of this end-of-life support. How long is it going to be supported? What type of patching is going to happen, for software? Even after the product has its warranty expired. If you have a smart light bulb and 2 years and 3 days in, so 3 days after the warranty expires, the application causes the light bulb to short circuit and burn down your house, that's an issue. So yeah, it needs to work beyond product warranty. And also monitoring the performance of said devices and applications, and also patching known vulnerabilities needs to be done until the end of a product's life cycle. For example, just take a look at Windows 7. Windows 7 ran out of support only a few, well, now it's a year ago, about. And in the meantime, we've had 2/3 entire versions of Windows in the meantime. So they are doing their, Microsoft is doing its job of end of support management. So yeah, proven solutions. Yeah, when you talk about, let's say, using cryptography in their applications, in their software, firmware, all that jazz, and they say that one of their developers or one of their, I don't know, tech people came up with a solution, that's a red flag. Because it probably hasn't been tested to the extent and rigor it should have been, and it's might be flawed. So yeah, avoiding custom and proprietary solutions is easy because there's a breadth of solutions already existing. For example, if we're talking about cryptography, it's like, okay, AES, DES. You can also talk about RSA if you're talking about asymmetric encryption, elliptic curve. There's a ton of options. And it might actually take more time to develop one than just to integrate these things. Second part is that usually these things are verified by certain, let's say, sections of the community or of the industry, quote unquote, and also by scientists, like some people that really go ham on the math and check that it's applying certain mathematical principles that make it hard to, let's say, reverse said solution. For example, if we're talking about the RSA algorithm, the whole thing semi works on, the factoring of prime numbers. And that's something that scientifically we still don't know how to do fast enough for it to be insecure. And yeah, vulnerability management. So establishing procedures for analyzing and handling security incidents, but also having a vulnerability disclosure system is important. But also maybe using certain platforms such as, I don't know, HackerOne or others. It's just platforms, where you can see some information going around, and I don't know, see a vulnerability fly by for a service you use and that no one else uses. That's pretty important because you can cache the information before actually having an incident. Yeah, security training is another important part. It's that not two people in in a company, or let's say group or team or anyone, should be aware of security. Everyone should, have a certain baseline understanding of security practices and privacy. Not even just, knowing of stuff, but, locking their desktop when they're leaving their desk, not putting passwords on post-its and just sticking it on the desktop, things like that. I mean, if they have it in the notepad that they put in their locked drawer, fine. If they're putting it on their desktop, it's just asking for an issue. These training activities need to be documented because you can then build upon older training activities and maybe rehash some things that weren't understood if there's an incident. And yeah, everyone in the team should have a certain role and certain responsibilities when dealing with cybersecurity practices and incidents and general elements of cybersecurity. It's not only the CISO or the DPO or anyone else that are going to have to deal with some incidents. Everyone is going to have to put in a certain part of their own time and, well, abilities to get stuff done. Yeah. Third-party relationships. We usually talk about this when we're talking about personally identifiable information, so PII. For example, if a third party is doing or is using or transforming any type of one of those verbs, private data, it needs to be done under a contract. Like it shouldn't be like, oh yeah, here's a USB key with private data on, let's say, 1 million of our users, and go ham on it. No, there needs to be a certain contract with certain defined limitations. For example, talking about, let's say, WhatsApp. WhatsApp was a pretty big issue 2 weeks ago. 3 weeks ago, sorry, where they have third parties that have certain contracts to analyze the information, maybe take something out of it, and they're all under contract. And that's usually talking about GDPR, but it affects pretty much everyone nowadays. Another part is to obtain consent concerning personally identifiable information. And by consent, we're talking about express consent or informed consent. People need to be informed that this information, like let's say phone numbers, is collected and what is going to be done with it. Which is something like if we're going to do some let's say some fighting with WhatsApp, they don't do that. When they had their prompt saying, oh yes, so accept our terms and conditions or we delete your account or your WhatsApp account, that is not technically consent in any way, shape, or form. That's a threat. Yeah. Another part, supply chain risk management policies. Now, I'm not going to talk about WhatsApp or any other company name because we were there, I guess, in December when SolarWinds happened. Yeah, that was pretty hardcore. And even with all the policies in the world, that probably wouldn't have mitigated much, or at least from what we know of it. So yeah. It also goes to show that even with the best policies and the best intentions, some things just go through there and just steamroll the entire industry. Right. The last part, we're getting through these, is technical measures. It's also by far the longest part. So, yes, the memes there's memes everywhere here. First part is hardware security. Security-specific hardware is the main point of, not contention, but of interest. So having a hardware-based immutable root of trust. A root of trust basically means that you have a secure perimeter around whatever hardware you're using with a secure CPU, with some runtime memory protection, and some tamper resistance, just slapped one on top of another. This usually you try to strengthen the protection and the integrity of the device. Sometimes it's just you add a security processor or a coprocessor that just acts as a root of trust, and the rest works on its own. Another part is identity and authentication means. Let's say trusted storage of a device's identity. Like, are you going to store it in RAM? Are you going to store it somewhere where it can be, let's say, modified? Or are you going to store it somewhere where it's write only once and then it's done? It's also protecting keys when the device is at rest, or even if it's in use. Preventing unprivileged, let's say, people or processes from accessing a security-sensitive code. If you're running, like, let's say, mini Linux kernel on an IoT device, like, let's say, Alpine Linux, because it's one of the smallest distros, and you're running it on, let's say, Pi 0, well, that's a bit of an issue, because at some point, let's put it that way, you might want to do a call to sudo. And if any other process can, because you've trimmed a lot of stuff, if any other process can access that, you're going to have issues. So yeah. Also, having again, a way to store keys, to establish keys. So yeah, you have these key establishment policies that are a pretty important deal nowadays. And finally, functional security, protecting it against local and physical attacks. Right. Trust and identity. Trust and integrity management. So having a hardware root of trust at boot. That's where our previous, security processor or security coprocessor kind of comes into there. It's that only that runs and then the rest runs. And that's pretty important because that's the one thing you're going to be able to trust before anything else. And it's the one thing that's going to authenticate other processes or authenticate other, let's say, components of your device. Code signing to avoid tampering is pretty good also. It's not flawless. I mean, we've seen it with SolarWinds. It's not flawless. There's a certain aspect of runtime protection or monitoring for installations. Once again, running Alpine on a Pi Zero, you might monitor installations. And the final, well, not final part, but it's keeping a safe state, like one state, kind of like in Oracle VMs, VirtualBox VMs. It's having a state you can roll back to, a snapshot that you can always roll back to and just reverse anything that has happened in the meantime. A last part is to have a certain protocols and mechanisms that kind of represent and manage trust relationships. So, for example, you need a protocol for, let's say, a humidity sensor to trust that it is, yes, sending data to the correct processor or to the correct, let's say, output, and that someone else, on the other side is getting it from the right component, not that someone can just, I don't know, plug in random values using, let's say, any tool. Strong default security privacy, right? So enabling security measures by default is pretty important. It's designing a system with operational disruption in mind. So if, let's say, the power cuts out and you have a, let's say, robotic factory, a factory with robotic arms, not that they just go randomly limp and, kill people by falling on them. Mechanisms for self-diagnosis. It's basically having security measures on by default. It's installing individual device passwords. I know that sounds ridiculous, but like the number of let's say devices that run with admin. I think I actually have a webcam courtesy. It's not a webcam, it's a security cam courtesy of the beer farmers, which the default password is admin. Yeah, bit of an issue. Data protection and compliance. So once again, personal identifiable information collection requires detailed, explicit consent. Compliance with GDPR being mandatory. So that's a part of the ENISA guidelines. That's pretty important. The issue is it's actually important whether or not your service is being developed in the EU at all. Because say that one person, let's say it's a US only service, right? Not that anyone here, or like, let's say, not that concerns particularly US people here on this call, if there are any. But let's say a US company does a US only IoT device. They would still need to be at least GDPR compliant, because GDPR applies also to citizens of the EU that are not in the EU anymore. It also applies to expats, which is a bit of an issue for everyone that kind of wants to harvest and sell and process data randomly. And another point is, having all rights towards their data. Let me just jump back onto WhatsApp, because it's a fun horse to beat. The all rights towards their data is something that they kind of disrespected when they said, oh yeah, we'll also harvest your entire contact book. And by the way, if you're not allowed to, give us any one of these things, it's on you, because just having them in your contact book means that we can collect them. That's a big oof. and also the fact that you actually don't know where it goes and how to retrieve it afterwards, because it's not in your data dumps at the end. System safety and reliability. Disruptions. Keeping that in mind, once again, factory robot arms. Having mechanisms for self-diagnosis and self-repair. Let's say, once again, what we're talking about, rolling back to a safe state. And finally, ensuring standalone operations. Devices should be able to work when not tethered to a hub. Now, there was this one story that happened a few, let's say, not weeks, but it happens semi-regularly, like with, let's say, Amazon Ring or Amazon Echoes or Google Homes or whatever, just blaring out in the middle of any type of conversation. Oh yes, we can connect to the Google Home servers. And then it does nothing. It doesn't work anymore. Like, okay, that's a big issue. So yeah, Home, Amazon Ring, Echo, etc., are very, very common examples of that. Like, for example, disruptions in that case would harm users if they couldn't get into their homes because they only rely on Ring to, do what it does. Secure software and firmware updates. One of the main bones of contention is over-the-air update capability because it needs to be able to do that. The bone of contention isn't that it can do that, is that it's secure enough to do that. If I'm jumping back to the presentation I showed earlier, the one by Smielum at DEFCON 27, he was able to change the contents of an update package and just push it to the device. That's a bit of an oof. Automatic firmware updates should be optional, but should be an option. And firmware updates should be backwards compatible because, yeah, to the extent of possibility, of course. Point on authentication is that authentication and authorization schemes should be device specific. Yet again, admin is a bad idea. And should also be based on threat models. Default password should require a mandatory change, even if it's admin or not admin. Default password should be changed. There was this one thing with Samsung TVs where the code was, I think, was 5 1s and 5 2s. That's also a big oof. Optional multi-factor authentication and strong passwords, pretty important as well. And resilience and recoverability. For example, 2FA codes, when you're using a Google Authenticator or whatever, they give you a list of codes that you can use if you lose your device. That's recoverability, for example. Now, authorization, the principle of least privilege. So yeah, application and services should be operating at the lowest level of privilege possible. Don't go running everything as root. Talking to InfoSec people here, so I don't know why I'm saying don't run everything as root, but yeah. Device firmware, right, should isolate privileged operations. So if you're writing to a database, reading from a database, these kinds of things should be isolated from the rest. Access control. Where's the meme? There's a meme here. Let's ignore the lack of meme for a second. So having integrity and confidentiality in all of your access controls. Once authorization to access some processes has been given, it's kind of necessary to enforce a certain security policy. Having local tamper protection on, including the encryption of storage mediums like SD cards, pretty important as well. Minimizing and locking down physical ports, like if you are having a I don't know, a Raspberry Pi in the wild, having its USB ports open is potentially an issue. And by potentially, I mean it is an issue. And then debug modes should be, reliant only on trusted connections. There needs to be a certain handshake that goes on for it to be not authenticated, but to be, authenticated is a pretty good word for that. A word on cryptography. So yeah, we were talking about not writing own cryptography or security processes. Yeah, having a certain robust encryption at all stages of, let's say, a transmission or a anything is pretty important. Key management is pretty important as well. Having strong encryption algorithms, strong keys, disabling some insecure protocols, pretty important. And devices should potentially be compatible with lightweight encryption algorithms and security techniques. And all of this should be scalable. I think you're starting to slowly get to the why no one can be asked to be, let's say, 100% compliant. Secure and trusted communications. Guaranteeing security, so verification, maximum emission. That's pretty much standard, let's hope. Ensuring the safety of credentials and traffic. I mean, with Def's part, just talk right before. Yeah, that's an oof at many levels. Signing in, signing and verifying content. That's pretty important as well. And only allow intentional connections. So I might see some of these overlap with each other, but it's pretty normal. We're starting to get to the end of these. So having secure interfaces and network services, let's say segmenting risk by isolating processes, devices, sensors, pretty important. Having, protocols to ensure resistance and resilience is also important. That if a device is compromised, it doesn't compromise the whole set of devices, poisoning the pool. Having sessions susceptible to incidents is an issue as well. And yeah, not too specific error messages. That's, I mean, if you're displaying the errors in your SQLI, a table when someone is trying to do a SQL injection, it's going to give them a few hints. Right. Getting close to the end. Securing input and handling output, also important. So yeah, validating input, filtering output. Once again, don't let people write script tags and other things in your form inputs, and other ways to trigger XSS. Logging, so recording all events, preserving these logs on durable storage. Not automatically delete after 2 weeks. That's a bit of an issue. And that admins can access these logs, or people with sufficient access should be able to access these logs. Monitoring and auditing, right? So, monitor regularly, having regular audits and reviews, performing penetration tests, right? That was it for that. Now, I'm going to give you the practicality breather. So that is the exact same thing we saw earlier, the example I gave you. And we're actually going to see some issues. Let's say an issue. Let's say this device uses, so for a reminder, IoT pacemaker, transmits vital info to phone monitors for variations, can send out alerts for a, let's say an ambulance to come, etc. Right. Example issues, if you're using Bluetooth Low Energy, well, you can probably sniff it. You can sniff it. You can potentially do a man-in-the-middle attack, depending on what type of data elements you have in there. Since the data is sent as, raw bytes of ASCII, data elements can be large and can actually just exceed the transmission unit size, which is how much bytes can be in one burst of Bluetooth Low Energy transmission. And for example, let's say that someone is spoofing, your device signature, whatever. You can trigger alerts with a certain amount of intent, or you can also not trigger them. Like, let's say if you're killing someone. Fun things. So when designing a process that could fix this, you have a certain duct tape methodology, which is coalescing information, transforming information, mapping that information, encrypting the information, checking the integrity, and setting some flags. So this is, once again, still the example. And that's something, as a developer, let's say it's low food chain stuff. So coalescing, let's say that we have a device ID, heart rate, ECG, EGG values, all that we talked about earlier. It's all these data fields. So you have some text, you have some numbers, some floating point numbers. Well, all of these take a lot of space. So yeah, device ID, heart rate, ECG values, EGG values. Let's transform them. Well, a text, like the device ID, you can have a text flag, something that identifies it as a flag. This would be the equivalent of a carriage return. A certain text size, so 8 characters is the amount of size you have. All of these, ASCII characters, 8 of them, and then another text flag. Pretty straightforward. So you can transform them as bytes. Then transforming numbers, once again to hexadecimal values. So you can represent data and also missing data. That's pretty important. Right, missing data is important. Map it. That way you can map, if there's a missing set of data, you have the previously seen space, you remove all the x's, you add a 0 to the value map, and then you just plug in your data. Encryption, so for example, using AES, something that's somewhat standard, certain key and an initial vector. So I use CyberChef because I like to cheat, but usually you would have a certain program that does that. Advantages of AES is that it's same size input, same size output. So you have data that's encrypted. Then you can add like a CRC for integrity checking. So you just plug the CRC at the end of that. And then you consider the same issue that Ethernet has, is that if you're going to use flags to delimit the start and end of a package or a data packet, is that, for example, if you're using the same thing as Ethernet, OX7E, it's 6 consecutive ones. Well, if you have 5 consecutive ones in your data packet, you might want to add a 0 in after that at each occasion to mitigate that risk of the flag being seen in the wild in the middle of a packet and then ruining your capture. Right, that comes down to this, which comes down to this, which is bytestring, which if we consider like a random thing where it would have been sent as CSV, it's sent as plain text of 62 bytes of variable size. Let's say the floating point is doing a typical floating point thing of doing 87.3777777, and then you just overflow. The advantage of, let's say, another method, which is slightly longer, is that first, as you can see, it's slightly obfuscated as text, like it's somewhat illegible. And okay, it might be 84 bytes, but it's fixed to within a few bits. So that's pretty much, I'm not going to say it's better, but at least it's fixed. And you have your integrity checks, so that's a CRC. You have a certain amount of encryption, that's a yes. And you're kind of building up a method that would then be compliant with, if used, let's say, when communicating between a phone and an IoT device. So, takeaways. We're getting to a conclusion, just in time. It's a multifaceted approach. having multiple approach vectors to security, to compliance. And it's something that is totally intangible for very small development teams, because asking development teams to do all that is, I mean, it's possible, but it's going to take them ages. Also, the procedural costs can be extensive. Because, let's say a pen test costs money. Having a specialist come over costs money. Designing, I don't know, prototype and printing out a few boards costs money. Everything costs money. And it also requires breadth of knowledge. Many people need to know many things. So the burden of compliance is that, time is basically a money pit when we're talking about our initial 4 hurdles. So long as time goes on, money gets drained. People cost money because, salaries, yet again. I couldn't find anything for money, so, money is money. And quality implies money because, if you want to be extensive about it, you're going to have to do more stuff, which implies paying more. So yeah, the reality check of it all, because I've just said a number of things, so 80 recommendations, and it's all very beautiful. Yeah, it's a very long list of requirements. Most projects don't actually have that many funds. The number of IoT projects that start off on Kickstarter are huge. And yeah, people want to develop their thing, not, oh yes, so we're developing an IoT device that does this, but it also needs to be compliant with this. It needs to be secure. It needs to be to have a secure root of trust, having all these things. It's like very big in how people approach it. And usually projects are kind of spearheaded by companies that often have investor deadlines. So it's the other kind of project, the non-crowdfunded project. So you have deadlines, you have cost-cutting initiatives, and that just breaks everything down. And people might be might think, oh yeah, let's use frameworks to offshore the problems to some other company, or use the cloud, or some other kind of solution provider. Yeah, that's kind of the big bad wolf of IoT. It's IT solutionism. It's basically taking a big shovel and shoving the problems to someone else, and not being entirely certain that it will work any better, or, yeah, big issues there. So this talk is available under CC by SA. Basically means share it however you want. Just stick my name at the end of it. And feel free to ask me anything. It is finally over. How many people did I lose?